So next week is about labs. We'll also prep for that test one quiz thing I told you we'd do to add some points to test one. And there will be time to just tack that little quiz onto test one. The quiz shouldn't be more than 15, 20 minutes long. The thing to study for that, we'll go over it on this day, but the last 10 questions on test one is what to focus on for that little quiz. And then that'll add some points to your test one grade. So that's our schedule going forward. I think I will leave these. I forgot we hadn't done redox yet. So we'll leave these for test 3, the energy stuff, and we'll just focus on oxidation reduction. Definition, okay. I have to flip to this for a second. I've added to this PowerPoint a couple of pages. This page is from your book, telling you how to assign oxidation states. I'll tell you what that is. This is from another book that I thought was just a little more straightforward than this. Whichever one of those you'd like to use, you can use them. So looking at these 2 pages, here's something that's very easy about oxidation states. Ions. I'll just say ions. The ions that you already know, for instance, calcium, if I said, what's the charge on calcium? You tell me +2. If I said chlorine, what's the charge on chlorine? You tell me -1. That actually totally coincides with what we call oxidation states. Without telling you what oxidation state is, the oxidation state, or sometimes called the oxidation number, for calcium, when it's an ion, is +2. For chlorine, when it's an ion, is -1. Straightforward enough. If you had calcium S, that just means a solid chunk of calcium. Then its oxidation state is 0. That's the charge on it too. So far the charge and the oxidation state are the same thing. It's only when we have molecules. Well, let me do this first. Chlorine 2. There's such thing as Cl2, Br2, F2. So I'm just going down the halogens. I'll say I2. Here's a few others. There's H2, O2, and N2. There's also S4. All right, these that are just elemental, the molecule is just the element, those are all 0 as well. So far, it's pretty simple what an oxidation state is. I haven't quite told you what it is yet. Ions are simple. It really is just the charge on the ion. What's weird is how you assign oxidation states in molecules. So if I just did H2O, there's the Lewis structure for H2O. Okay. It's really not a thing that exists in reality, the oxidation state. It's just sort of a bookkeeping trick we use. Because in oxidation reduction reactions, also called redox reactions, electrons transfer from one atom to another atom. And this bookkeeping game we'll play that I'll show you today teaches you how to figure out which ones are gaining electrons and which ones are losing electrons. The oxidation state on oxygen here, because it's the more electronegative, we just sort of pretend, and it is pretending, that these 2 electrons are there, and these 2 electrons are there, which makes that positive. and makes that 2 negative. I mean, this is showing oxygen has gained 2 electrons, so its oxidation state is 2 negative in H2O, and hydrogen shows that it has lost an electron, so it's positive. But this is not really the way we do it. I just want to give you an idea of what this bookkeeping game we're doing is actually doing to a molecule. There's just a set of rules you follow, which is what I've got in here. So in this PowerPoint, in section 8.9, you'll see a box that says how to assign oxidation states. And then this little thing on the left here where it shows fluorine, hydrogen, oxygen. That goes along with it. But I think if I just start going through this, it's kind of obvious. I think you can always assume that oxygen will be -2 for any of our examples. And it ends up being oxygen that you key on most of the time. And here's out of a different book that I thought to me is a little bit more straightforward. But what I want to do is just go through a bunch of examples. And I should have said, upload this PowerPoint that I'm going to use. It should make things more clear. So on this first page, I've listed on this first page on redox reactions PowerPoint, the questions at the back of the book that you can use for practice or the back of the chapter. But I have a bunch of these that I've used as an example in the past, and I will just take you through these. I think I'll actually move the camera. I'm gonna have to stop it. I can do this without too much trouble.